Hello, everyone. Welcome to the DI 101 webinar series. My name is Jared Evans, and I manage all the marketing efforts for Distribution International. This webinar series is an incredible resource offered to DI customers, partners, and associates. By partnering with our manufacturers and our industry experts, these webinars really deliver informative presentations about industry trends, new technology, new products, and product applications. We are extremely excited to welcome our strategic manufacturing partner, Integrity Products, for today's webinar presentation. Ahmad Rana, Director of Technical Services at Integrity Products, will deliver a systematic approach to asset integrity, focusing primarily on corrosion under insulation, which is a major influencer in our industry today. Ahmad has 10 years of experience in the industry, focusing in oil refining, petrochemical, chemical, and energy production. He has published research in several renowned journals and is the recipient of the NACE Graduate Student Book Award in 2019. We also have Carl Metcalf, Vice President of Business Development for Integrity Products. He will be joining Ahmad. We are very proud to have Integrity Products present today, and we thank them for their time. I do want to ask all of our attendees a favor. I know some of you log in under one login, but you might have several people in a conference room. If you could, just either, if you're a DI associate, shoot me an email, or if you want to just post in the little chat tab on the GoToWebinar panel and let me know how many people are in the room with you. It'll help us get a better idea of how many people we have attending. We want to do our best to keep improving these webinars, and having those statistics will help us do that. So I appreciate it if you guys could do that. We will pause for questions at about a halfway point of the webinar, and then we will again open for questions at the end. To submit questions, please use the questions tab on the GoToWebinar panel. You can submit your questions at any point during the webinar, and we will answer the questions during those 2 question periods. So you'll just type out your question in that questions panel, and then we'll receive that, and then we will read the questions and have our presenters answer them the best they can during those question sessions. So without further delay, I will turn this over to Ahmad with Integrity Products. Thanks, Ahmad.
Thanks, Gerard. Thank you so much, everyone, for attending this session, and thanks to Gerard for arranging this session. So as a part of this session, we're going to talk about a systematic approach towards asset integrity. So once we say that asset integrity, why we need that, why we need to have that on our assets. So we can see in these pictures on the left side, we can see an oil terminal that is on fire. Definitely because of some process malfunctioning, some leaky things, or some equipment damage. And on the right side, we can see like the facility, how it looks like once the firefighters have extinguished the fire. And we can see a vessel in this slide. We can see that, and there is a small ring, insulation ring attached to the vessel, and also we can see some dense corrosion on the body of the vessel. So if we just try to relate these two events, that like there is a corrosion and there was an insulation on the vessel, so definitely there was a corrosion under insulation while there was a fire in that facility. We cannot say that it's the reason of the fire, but that could be the potential reason of like some sort of failure in the facility. So once we say about the asset integrity, so the opposite of asset integrity, I would say, I can say that asset degradation. And the corrosion is the prime contributor towards the degradation of assets. So if we talk about the financial loss due to corrosion, it's being reported that 3.4% loss to the GDP of any industrialized economy is because of corrosion. And another textbook that says that it's a 5% approximately the loss to GDP. So it's we can say that 3.4% to 5% loss to GDP of any industrialized economy is due to corrosion. And if we just talk like in terms of the dollar value, so it's about $2.5 trillion annually, the loss to the GDP. That's a global cost of corrosion. So once we say that like this is the loss, and also like this is the amount, also includes the expenditures and the efforts that we have made towards corrosion. So once there is a corrosion, there is always a reactive approach. We replace something, we repair something, and the insurance companies they pay back the claims to the parties affected by the corrosion. And also there are certain measures in terms of paints and coatings, and definitely it's a huge industry. There is a huge investment in cathodic protection and corrosion inhibitors. And also the time we design the equipments or the vessels or the lines, we always over design them. We keep the factor of safety, we keep the corrosion allowance in that. We try to go with the high metallurgy, high grade alloys with the improved metallurgy. And we spend money on all those measures. And also there have been regulatory measures in place along with the R&D work. So every step that is being mentioned that needs money, and that actually constitutes towards $2.5 trillion loss annually due to corrosion. So once we say that what is being done as a reaction, so we have done all these efforts, corrosion inhibition, cathodic protection, so that is dealing with the corrosion. So what about asset integrity in general? What has been done? What is the evolutionary journey for the asset integrity? So moving back 3 or 4 or 5, 6 decades, so there have been the trend of conventional inspections. So the people the plant inspection people, they used to care about the thickness loss, visual inspections, then came the radiography, and all these inspections were being conducted as per certain checklist documented procedures. So once the industrialized, they had more database, more lessons learned, the more records, and everything was smart enough. They recorded everything, compiled everything in the form of degradation. So they were able to diagnose between and differentiate between the CUI from the atmospheric corrosion. So we differentiated that, and accordingly everything was compiled in the form of a document. We will talk about that in the next slide. And from the corrosion and degradation management, there came the sense of RBI, risk-based inspections, that became the basis. All these damage mechanisms, they led to the RBI. And then there was an effort on integrity operating windows. This is a brand new concept. Recently, 2014, very first publication is being issued by American Petroleum Institute about IOW. There is an API 584 document for that. And also, so IOW is the main concept is that we have to operate the equipment or the vessel or any asset within the limits that is safe for the integrity of the vessel. So we do not exceed the safe operating limits of the vessel. So that is the concept of IOW. And then the last thing is the fitness for service assessment. We do the assessment of any asset using some analysis, some simulations, some detailed engineering calculations. And there is another thing that is not mentioned in the slide. I would just like to add to that. That is about digitalization. So digitalization is the future of asset integrity. We would be taking the help from the augmented reality, virtual reality, and the artificial intelligence to perform the operations of asset integrity. So I just mentioned that the corrosion and the degradations. So the time the human race, they became more mature, they compiled everything. It was documented that this corrosion looks different from the corrosion C, and the corrosion C looks different from the corrosion D. So everything was compiled in the form of certain documents. So right now we have the latest edition of API, that is API 571, third edition, that is containing around 67 or I believe 66 damage mechanisms. And and those damage mechanisms are broadly classified into 4 categories. One is mechanical and metallurgical failures. Second one is uniform or localized loss of thickness. Third one is environmental assisted cracking. Fourth one is high temperature corrosions. So CUI, that would be the main area of concern for today's session. So that comes under the category of uniform or localized loss of thickness. So all these things are documented as per API 571. So we just mentioned about the CUI. So see what is CUI and what could be the problem. We will talk about that. But simply speaking, statistically speaking, 40 to 60% of the general piping failure of insulated piping, general failures of 40 to 60% is because of CUI. This figure is reported by many literatures, many research papers. So we can say it's a highly credible one. So once we say that the CUI, so what has been done in return? So it's a 40 to 60%, that means it's a considerable loss. So like there have been few efforts that have been made by the plant people, the inspection people. We strip off the insulations, we reinstate the insulations, we do certain MOCs like the change orders, we perform on the sites to replace the lines, and also we do some other measures to deal with the issue of the corrosion under insulation, loss of thickness, and the associated chloride stress corrosion cracking. And also we have to erect the scaffold to access the locations that are vulnerable to CUI. And also we try to modify the operating conditions. I mentioned the concept of integrity operating windows. So if we have to run a system at the lower temperature and the lower pressure than what is expected, so that means there is a loss of productivity, and the production rate is less, and also the quality can be compromised. So again, there is a financial loss towards that. But even we modify that to keep in the safe operating limit. And also we go with the extra protection and coating systems. And also recently there have been like a lot of there has been like advent of technology with the hydrophobic insulations, so with the water repellent technologies that are in place. And also we conduct the non-destructive examination, like the latest one is MDI, moisture detection imaging, infrared thermography, and also we go even with the general visual inspection by stripping off insulation. And the last thing is the effective design. It's a huge area, and I would say it's a gray area, because it's the most decisive one regarding the CUI, like the future of CUI in our assets that is dependent on the design. So all these are the efforts that are actually made towards CUI to minimize the probability or the consequence of CUI. So I just introduced a second concept that was about the RBI, risk-based inspections. So I would say like, we know that like what is the inspection, we need to conduct the ultrasonic thickness, or we need to conduct the radiography. Then what is the risk-based inspection? What is the specific technique that we need to implement? So RBI is simply that there is a mindset that it takes into consideration the risk, and actually it can help us to organize and to we can say strategize the inspection activities. Same radiography and same ultrasonic thickness we do even with the RBI, but in a more systematic and smart way. So we can focus on all the required inspections and only the required inspections. So and how this mindset works, so we just need to know what we need to inspect. So we are inspecting the CUI, for example, and why we are inspecting the CUI, because it's a bad actor. We don't want it to be in the system, and it can compromise these systems. And where we can inspect, so definitely the locations that are vulnerable to CUI, the locations of moisture ingress. And when we need to inspect that, so that is based on certain set intervals by the inspection program, and how to inspect. So that is the question. We have the different measures in place. We can use the water detectors. We can use the non-destructive examinations. These are the different measures. Which one we need to use where? So that is about how we can make our inspection programs more smart through the use of RBI. So here is the real benefit of the RBI process, like I would say quantitative RBI. It's a detailed RBI process. So we come to know that which of the system or which of the equipment or which of the piping or the loop is vulnerable to CUI to what extent. So we can see like it's called a 5x5 matrix. We can see the red areas that are more vulnerable to CUI, and the high risk areas in the green one is the low risk area. So the quantitative RBI helps to prioritize our inspections, so we can focus more on these areas with the high risk, and we can least focus, we can focus less towards the green areas, the safe areas in the beginning. So we have to attend the high risk zones on the first priority. So it's about prioritization of inspections. So moving back towards the topic of CUI, corrosion under insulation. We as a company, Integrity Products, what we do and how we work to deal with the CUI, and what is the mindset while we design our CUI mitigation products. So we are an established R&D research and development company. We have a full in-house R&D system, and here is the roadmap. So we take the help from the published literature, standards, recommended practices, published research papers, as well as the voice of our customers. So we deal on day-to-day basis with all these things. We design something, we come up with some certain solution, and we prototype that. We do the shop validation for that specific product, and to look for the pros and cons of that product, and we validate that. We modify that, then we send it for the field trials, and accordingly we take the feedback of the field personnel And then accordingly, we validate that, we make some modifications, and finally we come with some finished product. So here is a complete cycle. We learn, we develop something, and we learn from the lessons, and we finally come up with something and market that thing. But the thing is that everything that we learn during this journey, we'll try to give the feedback to the published literature. We try to publish the case studies. We try to give the feedback, and in the form of research papers, articles, white papers. This is how we contribute towards the scientific content. So moving towards our approach, systematic approach, how we design our CUI mitigation products. So the CUI products that we design and we have developed in the recent years and also in the future, there is the same mindset. We go with the multi-barrier approach. So the multi-barrier approach is meant to ensure that even if there is a moisture in the surrounding, we do not allow the moisture to intrude into the system. So we have to develop some practical and viable solution, an affordable solution, so that the moisture cannot get into the system. And if it gets into the system, it doesn't stay trapped over there. It has to get out of the system. And before it can get out of the system, we should be able to detect that by using some cost-effective means, not using the high cost, I would say, non-destructive examination techniques, or that is not a frequent one. So we can use some solution that is in place and that can detect that can drain that moisture. And also we are able to do the regular inspections without compromising any other thing in the system. So that is our mindset, how we design our products. So these are our key principles for CUI mitigation products. So once we say that the CUI, corrosion under insulation, the main thing is the insulation. That is the most attractive and the sounding thing. One is corrosion, one is insulation. So we can say that it's coming from insulated systems, maybe or may not be. But the thermal insulation is the common area of interest for everyone in this group, because with our distribution partners, with asset owners, whoever is attending, that is the common ground of interest. So there are like few facts about the thermal insulation that they can make up to 1 to 3% of the capital cost of the facility. We know that there is a high priced, there is a high cost investment on the pressure vessels, gas turbines, steam turbines. Maybe sometime we think that it's a very low cost item. But eventually this, because since it's a bulk in numbers and there are like associated challenges with that, it can make up to 1 to 3% of the capital cost. And again, as I mentioned earlier, it's a driver for 40 to 60% of the piping failures. And another thing that I just came to know that 81% of the piping failure for the piping up to 4-inch piping failure are like, out of that 81% are because of CUI. Just imagine the thing that is 1% and it's contributing up to 40 to 60% failure. So how much decisive is that? That is the insulation. And also like the quality of insulation, the design of insulation, depending on how it looks like and how it performs, it could be the driver for other bad actors like CUI, corrosion under insulation, chloride stress corrosion cracking, crevice corrosion, galvanic corrosion, and atmospheric corrosion. These are the different degradations that actually mentioned in the API document. So these are all the bad actors, like I just mentioned previously, they were resulting from the emitting from the insulations. But what is the point of view of the asset owners? What is the level of understanding? Majority of the cases. So these are certain areas that asset owners, our customers, they might struggle with that. So like the time they specify the insulation in their specifications, they might not specify that CUI compliance of insulations or coatings, because the ASTM G189 is the base document that guides us how to do the testing of the systems for CUI compliance, for CUI resilience. And also the ratio of the shorts and fibers. So that is also a quality concern, quality KPI. So there is an applicable ASTM. So shorts and fibers, this is the least known concept with the asset owners. And there is a certain allowed limit as per ASTM standard. And if we speak about I'm just talking about the mineral wool insulation, I would say, or stone wool insulation. So again, that is a combination of like shorts, fibers, binders, and can contain multiple things. So there could be potential inconsistency with the composition. And also looking back at another ASTM, I believe it's C585. It's not mentioned on the slide, but it's I think C585 or C535. Please correct me if anyone in this group knows that. That allows for the thickness variation up to 25% in the final finished mineral wool insulation. Apparently, it looks okay. Like someone might not be having a concern, but we will talk in the upcoming slides how it can become a concern. And also the low point drainage, there might be least discussion about that, or there could be some discussion. And another thing is about the hydrophobicity. So do we think that the water repellency of the insulation is enough for CUI mitigation? We know that it's a great thing, but what about at 6 o'clock position, the low point drains and all these locations? Even it's mentioned in the research paper that hydrophobicity is a concern, especially under the immersion conditions. And we know that in 6 o'clock position, the water is likely going to stay, especially if there is no drain plug or there is no drainage system within the insulation. So talking about I just mentioned the word drainage or the low point drains in the system. Excuse me. So moving back to the best practices, so there is a standard that is called NORSIC. It's a Norwegian standard. I would say it's the third most credible document because even it's mentioned in the API, it's being cited in the API 583 at multiple locations. So this standard says that the insulation system should be capable to, it shall ensure drainage at low points. So that means our insulation systems should be able to drain out the moisture at the low points. Low points, I can say that it's a 6 o'clock position. And recalling API 583, so that says in the clause 9.4.6.2, that says that like system should be having a small diameter drain holes that can be drilled to allow any water accumulating in the insulation systems. So that means both of these standards are in consensus that there should be some way to drain out the moisture from the closed insulation system. Keeping in view that Integrity Products, we have developed our own drain plugs, and for those drain plugs, we have done the research and development study in-house. So what we did, we used 4 different systems of insulation. The first one, we can see the system A is containing the drain plug, I would say perforated liner to keep it like a non-commercial name because it's submitted for certain research paper, it's research journal. So I would say the perforated liner. So perforated liner or drain plug, and in combination with the contact-free insulation. So contact-free insulation, we have the spacers. We will talk about that in upcoming slides. So first system is with the contact-free insulation system with the drain plug. Second one is a contacting type, like a conventional insulation with the drain plug. Third one is containing the 6 mm drain hole as per API 583 recommendations. So they just say that we have to drill a drain hole. They don't say anything like any robust or some hardware in that location. And the fourth one is the conventional system, the contacting system without any drain hole, without any drain plug, nothing in that. So the fourth one is the one we encounter mostly once we go to the field locations. So all those systems were tested by using some testing. So what we did as a part of the testing, we subjected every system to 4 wetting cycles. So each system was subjected to 4 wetting cycles. In the first cycle, we introduced 800 ml of the water. In the second cycle, we introduced 700, the third one 600. So what we did, we added 800 ml and allow it to drain through the drain plug or the drain opening. So once the drainage stopped, it stopped coming out of the drain point. And after a few hours, the system was subjected to the second wetting cycle. In the same way, we allow it to drain. And once the drainage or the dropping stopped from the drain point, and we went for the third cycle and so on. So the amount of the moisture that came out, so the volume of the water that came out, we measured that volume and we tried to look for that, how much water is being trapped in the system, because the trapped moisture is a concern. So we can see in this graph, the graph A, we can see that the blue line, the lower line is having 100 ml out of 800 ml, 100 ml is being trapped in the very first cycle. But in the second cycle, we can see that the insulation is a bit saturated, so it's not trapping any moisture. So every ball, like 700 ml out of 700 ml, almost the same amount came outside from the drain hole. So same way, I would say drain plug. So the blue one is containing the drain plug and contact-free system. So this way it's giving a comparison. And on the right side, we try to look for that. So one is the trapping of the water. The second KPI is that the wetting of the pipe. Even if the moisture is being trapped in the system, but it's not wetting the pipe, so it's not a concern. The concern is the time when the moisture comes in contact with the metallic pipe and it starts a CUI process. So keeping in view the geometrical configuration and the gap and all those things, we did some calculations because we cannot run the simulation for this one. So based on this trend, we try to look for how many cycles each system needs to start the CUI. So with the blue system, that is a contact-free system with the drain plug, that needs 96 cycles of the wetting to initiate the wetting of the pipe. And unlike this system, the other systems can soak the pipe in 4 cycles and 3 cycles, and the closed system can soak the pipe in the very first cycle. So to double check that thing, we stripped off every system and to look for the wetting of the pipe. And except the contact-free system, the wetting was found on every pipe. So that means contact-free system was still resilient. Before stripping off the insulation, we did the MDI, moisture detection imaging. It's a sort of X-ray technique that is used to detect the moisture trapped underneath the cladding. So we try to look for the moisture. The system A and system B are containing the drain plug. The system A is the drain plug with the contact-free system, and the B is the contacting system. So and the C is the conventional one without any drain plug or drain opening, and the D is the one with the drain hole. So we can see in these figures there are certain bright spots. So bright spots are the indicative of the moisture. So we can see that dense moisture is existing in C and D, it's more dominant. And even we can see with the 6 millimeter drain hole, next to the 6 millimeter drain hole, there is a considerable accumulation of the moisture in the figure D. We can see that. So next door to 6 millimeter drain hole, the water is still stagnant over there. So that was the, I would say, visualization of the moisture. So again, I mentioned the word like using the drain hole. So someone might say that, okay, what is the benefit, extra benefit? Okay, so even if with the drain hole, I'm able to drain out the certain and considerable portion of the moisture from the system, then why we need to spend, why we need to make an investment on the drain plug? It's a perforated liner. Why we need to buy that thing? Why need to have that thing in place? So that could be the common question we might expect from the end user or from our customers. So moving back to the APA recommendation that says that the hole has to be drilled in the jacketing. So once it says that the drilling, so we have to be careful. So heads up when someone says that we have to drill the hole in the jacketing. I mentioned the concern previously that there could be a thickness variation in the insulation plus minus 25%. So that means if I'm buying an insulation from any provider, insulation supplier, and I specify them I need a 60 millimeter thickness insulation, thick insulation of 60 millimeter. And since they are supplying the product within the ASTM compliance, so they can give me that they have that flexibility to give me the insulation of 48 millimeter to 72 millimeter and claim that it's a 60 millimeter. And if that 48 millimeter insulation I receive from them and it's being installed in the place and I have to drill in the jacketing, and I think that it's a 60 millimeter, then there is a high chance during the drilling with the power drills, as API says, now use of the drilling. So while drilling with the power drill, I can hit the pipe. There is a high chance. So I would say it's a blind man's art. So someone can easily hit the pipe. And if someone, he or she is so smart, like they can judge that once it's touching the pipe, they can stop the drilling, even if they stop the drilling. So the worst case scenario, they just make us through hole through the pipe and puncture the pipe. Second scenario is that they make a small scratch on the pipe, or I would say small crater on the surface of the pipe. Then what can happen? Looking back to the principles of the galvanic corrosion, going to the electrochemistry. So that says that like the galvanic corrosion rate is high if we have a high surface area ratio of cathode to the anode. So now considering this fact that small portion scratched surface because of that drill bit would be a fresh cut surface. So that is likely to work as an anode compared to the rest of the pipe that is having the corrosion or the coating or anything that would turn out to be a cathode. So the coating area ratio is much high compared to that fresh cut surface, or maybe it's only a 6 millimeter, that crater on the surface of the pipe. Just imagine how quick the galvanic corrosion would be in that scenario. And like In the worst case scenario, there could be this small scratch on the pipe will turn into a pinhole maybe in few weeks or few months, and the pipe will start leaking from that location. So here is the consequence of that using the drilling in that jacketing. Another concern is that with the drill hole, another challenge is that since the moisture, once it comes out of through the drain hole or the drain plug or anything, that is not a clean water. It's not a pure water. It's containing the dissolved gases. It's containing the suspended solids. It's containing maybe damaged coating. It contains a lot of things, and it can potentially clog the drain hole. So we need a system to have it to clean it up like frequently. And also the concern is that due to pipe vibrations or due to thermal expansion of the stone wool insulations, so the hole in the jacketing can get misaligned from the hole in the insulation. So once these get misaligned, again, this hole would be clogged. So here is the thing, what is the benefit? What we are offering, the drain plug, the integrity drain plug is containing the self-tapping design. So that means we don't need any power drill for that. It can sit on the pipe. So we can see that there are certain sharp edges. So these are made from the polyphenylene sulfide, this drain plug. So it's not going to scratch the pipe. So like once we're installing that without any mechanized or the power drill, so it's not going to touch the pipe. It's not going to scratch any coating on that. And plus it's a robust design. It can stain the system. It can drain the moisture. And even in the event of the pipe vibration or anything, it's not going to misalign. And the third thing is that, and it's reusable. So since API 583 mentions the concern, achieving the rust-free drain hole is a maintenance nightmare. So with this one, we can remove this drain plug and we can clean it and we can just blow it with the dry air and we can install it back. So it's a multiple time reusable product. So that is the added benefit. And I think we are on the slide. Yeah. So I think, Jared, we can take some questions if the time allows.
Okay. Thanks so much. None have been submitted yet. We'll give it about a minute in case anybody has any questions they want to submit. Again, just use the questions tab there on the GoToWebinar panel, the control panel. We'll give it just a minute, see if there are any questions. Then if not, we'll move on and come back to questions again at the end. Alrighty, it doesn't look like any are coming through, so Ahmad, why don't y'all go ahead and proceed, and we'll come back and see if there are questions at the end.
Okay, perfect. Thank you. So I just mentioned the word contact-free insulation system while I was talking about the testing of the drain plugs. So what is contact-free insulation and why we need that? So recalling back API 583 first edition, it says that contact-free insulation systems prevent water accumulation and the chlorides build up on the steel surface. So that means it's a good thing to have the contact-free insulation system. And also in another clause, 9.6b, it says that in the last paragraph, like last part of the sentence, keep wet insulations from direct contact with the insulated surface. So that means this document is again and again emphasizing on the need of having a contact-free system for the insulations. Moving back to NACE SP198. So we were talking about the myth that whether the insulation is the reason of CUI or not. So NACE SP198 is breaking this myth. It says that 2.1 carbon steel corrodes not because it is insulated, but because it is contacted by aerated water. So that means the contact of the water is the concern, not the contact of insulation. But when the insulation is wet, then even the contact of insulation is a concern. We have to have certain system that can keep the soaked insulation away from the pipe. And again, it's in 6.7.4, it says the same way with the types that direct water away. We have to keep the water, prevent the water from reaching the pipe. So considering that thing, to achieve a contact-free design, we as Integrity Products, we have designed 3 different types of spacers. So spacers are meant to maintain the gap between the insulation and the pipe. So the first one in the left side, we can see it's made from silicon. It's a high temperature silicon and it can sustain up to 240 degrees Celsius. And it helps to achieve the minimal contact, minimum possible contact points. And for the installation of this type of spacer, we need a banding. So it has to be placed on the pipe and in a circumferential way, and with the banding, we just keep it tied to the pipe surface. So the benefit of this sort of system is that it's good for the system having the vibration, because for the vibration there could be some slipping of the spacers, or they can get misaligned, or they can get damaged. So it's meant for the system with the vibration. Second one is made from the polyphenylene sulfide. It also high temperature material. So the benefit is that it's easy to install. It's quick to install. You don't need any banding wire or non-metallic banding to install that. It can directly, with that sharp edge, it can directly be stabbed on the inside of the insulation. So it can sit between the insulation and the pipe without any extra banding or anything extra adhesives. And it helps to achieve the minimal contact. So we can see only two legs on that. So it can sit on that, and it's able to withstand also the high temperature. And the third one we have is PTFE or Teflon wrap. It's also meant to maintain a gap, and it creates a complete separation between the insulation and the pipe. So with that, it's having a dimpled profile. With the dimpled profile, we can maintain a gap of 6 millimeter between the pipe and insulation, and also it provides a impermeability. So this sort of wrap is best in the applications where there is a risk of chlorides leaching on the pipe, or there could be some corrosive things from the environment that can touch the pipe. So it provides a contact-free design with the impermeability. So with this one, with the spacer wrap, PTFE spacer, I would like to mention that it's being used on the trial basis. PTFE spacer on the trial basis, it's being used on a 3-kilometer pipeline project in Alberta. So because our customer had some specific application that was meant to protect the leaching chlorides from the insulation to reach the pipe. And here are certain snapshots how they look like once they are being in place. With the silicone spacer, we need the banding wire. With the PPS spacer, we need the direct. It can be installed by direct stabbing without any other wires. And in the third picture, we can see this PTFE or Teflon spacer wrap installed between the pipe and the insulation, and also we can see the shiny cladding in that picture. And here is another product that we are offering, integrity water indicators. Quickly recalling back API 583 that says water indicators can be installed at those positions to indicate the presence of water. So that means these indicators or detectors should be used to detect the water. So keeping that need in the mind, so we are offering this integrity water indicators, because the real benefit is that it can replace the initial NDE efforts, because for the non-destructive examination, using non-destructive examination can be costly and can be challenging to detect the moisture. For example, MDI, infrared thermography, we cannot make that inspection on each and every loop. So that we have to be selective about that. So for the initial NDE screening, we can use the API 580, this water detectors as per recommendations of API 583. And if we talk about the working principle, we can see a small gray ball. It's made from the elastomer. That gray ball is sitting in the orange portion. So this elastomer ball is having the capability. It can swell, it can expand once it's contacted by the water. So once it's wet, it starts expanding, and it forces the orange portion out of the barrel. So once it goes out of the barrel, that gives an indication that there is a moisture in the system. And accordingly, the person whoever is walking in the area, they can get an idea that this pipe is having the wetting issue. And there are 3 benefits of that. So this product is offering 3 benefits. First of all, it can allow the detection of the moisture. Secondly, it will also work as a drain plug. So any moisture that is coming, that can also get drained from the system. And the third benefit is that it collects certain portion of the drain moisture, so that can be subsequently used for the sampling analysis. So if any lab personnel wants to use this, wants to know what is the composition of the moisture that is coming out, it can also contain that. So these are 3 benefits. And with this elastomer ball, it's Once it gets dry, it can contract back to its original position, so we can use it, reuse that multiple times. So another product, so I would say it's a flagship and the very first product that we as Integrity Products we created. So quickly recalling back the concern from API 581, so that actually I would say it's a criticism on the conventional inspection ports, because the API 581 mentions that promptly replacing and resealing of the plugs is imperative. And if the plug is not capable to seal itself, then it's a concern. It's a maintenance concern. It's a concern for the inspection programs. And since it's a concern with the conventional system, so keeping in view that need, we have developed the integrity plugs that are actually meant to cover these CML, corrosion monitoring locations, or TML, thickness monitoring locations, by providing a moisture barrier. So here is how it looks like. So these are actually sitting on the pipe, certain field shots showing our, I believe it's a 14-inch inspection plug that is installed on the pipeline. So they will allow to retain a moisture barrier on the pipe, and also will allow the inspection persons to do the inspection. They can just they can open this inspection port, conduct their inspection, and they can reseal that, and keeping the moisture barrier. And it's made from a high temperature silicon, and silicon is applied on a flexible metal skeleton edge trim. So basically it's a flexible metal that allows it to precisely sit on any surface profile or any curvature, any radius. It can sit accordingly on that. And it's available, and the benefit is that it's available in the multiple sizes and the shapes. We have this in a 9.5 inch, 13.3/4 and 14-inch, 3 different sizes available, and also it's available in the round shaped. And it's also offered in another material, and that is EPDM. Instead of silicon, we have the EPDM that is relatively, I would say, that is relatively cheaper, because it's applicable for the medium temperature application. So we are not basically forcing our customer to go with the high temperature application, high temperature silicon, even it's for the medium temperature application. So we have the availability in 2 different types of materials. So again, I would say it's advantageous over the other commercially available inspection plugs in a way, because it's a flexible. It can sit on any profile. And plus, with this packing, we are offering a QR code. We can scan that, and we can get the installation instructions. And also, it's having a template, so it will allow precise cutting of the metal jacketing, and so that any person can easily install in that. And here are certain field shots actually showing our 3/4 round plug and 9.5 inch oval plug, and how they look like in the real life, I would say. And another thing that is, we call integrity pillows. So this is our product that we are offering to fill in the heat barrier in the locations of TML. So recalling back the concern of with the conventional inspection ports, once the insulation is removed using the cutout insulation, so there are 3 major concerns. Either the insulation is not restored back properly, or like in the worst case scenario, we can find it missing from that location. And the third thing is that if we are frequently replacing and putting the insulation, doing the inspection and putting it back, it can get wet with the time, and it can lose its efficiency. So definitely we need some system in place that can retain a heat barrier, the moisture barrier in that location. So we have designed this to develop these integrity pillows that are used in conjunction with the integrity plugs. So they sit in between the cutout insulation and underneath the integrity plug. They are made from a high temperature resistant fabric we call vermiculite with 1-inch e-gloss core, and it can sustain up to high temperature of 1100 degrees Fahrenheit. And that is a benefit for that. So another product we are offering is termination gasket. So quickly recalling back API 571, it says about the vulnerable locations to CUI. It says first few feet of a horizontal pipe adjacent to the bottom of a vertical run are vulnerable to CUI. So basically, horizontal pipe next to the vertical pipe is the location of CUI. Why that is a vulnerable location? Because of the effect of the gravity. any moisture that is collected in the any condensation or the moisture intrusion in the vertical pipe is likely to travel down and get stagnant in the horizontal location. Here we can see a figure of how like it's a worst case scenario, how the insulated systems can look like. So the horizontal section we can see with the next to the elbow, we can see that there is a huge intrusion of the moisture from on that location. With that termination gasket, we can potentially seal those locations and can stop the moisture intrusion. And another added benefit is that since the moisture can travel because of gravity, because of some thermodynamic principles, it travels from one location to the other within the insulated piping. We have to stop that, I would say, transmission of the moisture. So considering that thing, integrity termination gaskets, they also allow compartmentalization, or I would say restriction of the moisture within certain location. We can confine the moisture. We can stop the propagation. So the integrity termination gasket, it's made from a solid state silicon compound capable to resist temperature, same like 260 degrees Celsius high temperature. It can precisely fit on different pipe sizes and different insulation sizes. And the benefit is that you don't need to make any fabrication on the site. It comes in the pre-cut pieces. And unlike metal caps, there is no risk of hand cuts, or injuries, or the I would say time-consuming installation, or the use of like the sealants in a way that the way we use on the metal end caps. And you don't require any specific skill set to install these termination gaskets. So, and there is no risk of scratching of the moisture, damage to the coating, damage to the heat tracing, while these integrity termination gaskets are installed in place. So here are the field shots showing the integrity termination gasket on the terminating end of the horizontal pipe in the left picture, and the right side we can see on the vertical pipe run. So how it's sealing the end of the pipe. Quickly recalling API 583, that mentions the concern about the corrosion issues with the appurtenances. So appurtenances could be brackets, reinforcing pads, or anything that is projected outside the insulation. For example, the clamps, or some boards that are actually projecting out of the insulation. So those locations are the area of concern. So we can see in this figure on the left side, we can see some clamps that are actually projecting out of the insulation, and also we can see certain gaps in the cladding, so in the jacketing. So that those gaps could be the areas where the moisture can intrude into that, and also these clamps could be the location where the weathering is impacting and deteriorating the clamps. And also with these clamps, the concern is that the temperature of these clamps is high compared to the ambient conditions. So it would be a location of the heat loss from the pipe and from the piping system to the atmosphere. So with the integrity clamp covers, we can protect these clamps or the projected portions or the appurtenances by covering them. And also we can maintain the heat resistance barrier by filling those clamp covers, because they are non-metallic. We can fill them with the insulation, and we can stuff it with the insulation, and we can install it on the place, and they can maintain the heat barrier. They can protect the clamps from the weathering. And also the added benefit is that they can replace the conventional metal boxes. We might have seen that we have to build the metal boxes by cutting the jacketing. So there is a time required for that. There is a workmanship cost for that. So it can easily replace that. And it's quick and easy to install, and because of its flexible design, it can fit on different corners and the different shape profiles. So now we just spoke about the corrosion damage to the metals, to the insulations. Now it's time to talk about the jacketing. So we might have seen the corroded jacketing in the fields. So if I say that, like, whether it's a concern with the jacketing material or it's a concern with the atmosphere, it could be a concern with both. But the main thing that is actually contributing to the jacketing damage is the screw. So the selection of the screw and the design or the geometry of the screw is the main concern that could be leading to the jacketing damage. So you might have seen that asset owners, they make a huge investment by buying the jacketing and installing that. And sometimes we see the conventional stainless steel screws with the metal to metal contact. The problem with that, due to the metal to metal contact, there would be a crevice formation leading to the crevice corrosion, and also the metal to metal contact improper selection, there could be galvanic corrosion. and also in certain insulated system, like on the reactor floors, on the regenerator systems in the refineries. So there could be the vibration in the system, and due to that vibration, the corroded screws can break. Once there is a fracture in the corroded screws, so the jacketing is gonna be damaged from that location. It would be wide open, so we might see damaged insulation on the systems. So that could be one of the reasons, the jacketing due to screws and the jacketing of the jacketing corrosion via screws. So this is something how it happens in the real life. So as an integrity products, we are offering the Gerbil screws. So Gerbil is the manufacturer, and we are the exclusive Canadian distributor for these screws. So what is the specialty with these screws? They are made from the duplex stainless steel material, with having a more corrosion resistance and more fracture strength. And also they are made from they are having a pre-installed HNBR washer. So it's a non-metallic washer that allows it to fit over there without any formation of crevice. So we can eliminate the risk of crevice corrosion, galvanic corrosion, and weathering by the proper selection of material. So here is the concern. Someone might say that it could be a little bit costly compared to the conventional system, but I would say it's a huge return on the investment. We might spend a huge amount on the cladding. By improper selection of screws, there could be the jacketing damage. So it's a huge return on the investment. So these are our some of the latest products that we have recently developed, and I would say it's a hybrid vent and drain system. So how it looks like in the real life. So we are having a pipe with the PTFE or Teflon wrap, and with the insulation, mineral wool insulation, and the outer side of mineral wool insulation, there is again a perforated non-metallic wrap. So the outer perforated non-metallic wrap is meant to eliminate the moisture between the jacketing and insulation, and the inner wrap is meant to achieve a contact-free design and to eliminate the moisture between the metal and the insulation. So this sort of system is having the vents at 9 o'clock position, and so along the length of the pipe, it would be in a zigzag manner. So the vent we can see on the 9 o'clock position of the pipe, and the next vent is going to be at 3 o'clock. So this is the way they work in a zigzag manner. And also we can see the integrity drain. So integrity drain, it works like a drain plug, but the benefit is that it's offering more area. Especially it's best for the high, large diameter pipelines, where we need to drain the considerable moisture for longer durations. And it's made from the high temperature, I would say medium temperature EPDM material, and it can also conform to the various sizes and various shapes because of the flexible metal trim within that EPDM system. So this is how it's going to look like in the real life, this sort of system. So giving back. So once I say, we develop the products, we sell the products, we are in the business world, but how we give back to our partners and the associations and the scientific community and the academic community. So we are the member of American Petroleum Institute, and we are actively participating in their standards like 583 and 581 development process. And we develop the publications and the white papers. So these are certain magazines and journals. We have an active affiliation with them. And also we have the affiliations with the associations and associations like NACE, National Association of Korean Engineers, API, and also in terms of the academic institutions, we have the collaboration with NATE, and our inspection ports are being used at their apprenticeship program, so that the future workforce, they can learn about the trends. And I'm just quickly mentioning about the NACE. I would be presenting at the NACE Ottawa show on October 21st. So that is a presentation about the drain plug. And in the NACE 2020 show in Houston, I would also be presenting. So in speaking about the availability of the products, so Crossroad CNI is the distributor in Canada, and Distribution International is our sole distributor in USA. So we have an active and long affiliation with DI and Crossroad CNI. And speaking about our end users or the customers, so this is the clientele showing the logos of different companies. We have active affiliation. And at the end, I would just like to throw some questions on the participants. If someone is from the asset owner side, so I'm directly, I would say, confronting you guys with these questions. and especially with our distribution partners, with our field representatives, so they can direct these questions to their customers, that whether the CUI is a concern on the project, whether they have an established entity program, the type of insulation inspection ports they are using, and do they think that these are adding the value to their organization, or do they think that it can potentially add the value, and like the hierarchy of those companies, who is responsible for all this technical decision making. And if you have any further comments or suggestions or the feedback of the customers, you are welcome. You can reach us anytime. And thank you so much once again for your active listening and for your participation. And thanks so much, Jared, once again. So if you any questions, you can direct us.
Thanks, Ahmad. Great information there. I'll give a minute or two for anybody to submit questions. We don't have any submitted right now, but while we're waiting, I just do want to thank you, Ahmad, and Carl, for partnering with us on this webinar. I think the content and information has been very helpful. I know it's been helpful to our DI associates, and hopefully it's been helpful to our great customers that are on the webinar with us as well. So we appreciate you taking time out of your day to partner with us on this. I do want to say that for anybody who might have some colleagues that have missed this webinar, we will be posting this on our YouTube channel. If you go to YouTube and just search Distribution International, you should find our YouTube channel, and we'll be posting this entire recorded webinar there. So feel free to share that with your colleagues. We do have a question here from Jason. He asks, do you have any pictures of actual installations of these products?
Like you mean installation videos or something? Or like,
I'll tell you what.
If you just go, yeah, like.
I don't have. We don't have a ton of people on, so let me just unmute Jason so he can ask verbally.
Yeah, like this is actually taken from a field shot. It's with a pipeline in Alberta, and how these like clamp covers are being installed in place. And like if we talk specifically about the instructions on how to install, you can go to our YouTube channel of Integrative Products, and you can get all the installation instructions over there. And even if we supply certain product, we give with a QR code on that. All you need to do using the smartphone, you need to scan that QR code, and it will take you directly to the installation video.
Thanks, Jason. You are in.
I was looking for some. I'm curious about the spacer, the spacers to keep the insulation off of the piping right here. I'm interested in seeing what that PFE wrap looks like that's between the metal and the insulation in an actual installation. Does it affect the aesthetics of the leg?
So Jason, yeah, thank you. Yeah, so this is a relatively new product for us, and it's just gone through all our kind of testing requirements, and we've got it being trialed with a large project here in Alberta over a distance of 3 kilometers. So from that trial, we're going to be producing a lot of additional data and a lot of kind of field install photos as well. So at the moment, we kind of just have these animated type pictures. We've done some shop testing that we have photos of, but really this new trial that we're working on is going to give us that kind of data and the field shots and in more kind of install information that we require at this stage.
Alrighty, I don't see any more questions, so I think we're good. If you do have any questions, anybody on the call, feel free to email me. I am putting my email address in the chat right now. And if you think of any questions and you want to email me, I will be happy to relay that question to Carl and Ahmad and get that answered for you. Alrighty, thank you guys again so much for your, oh, looks, we have one question come in right here. It says, why overlap, why were overlap sealants not mentioned?
Oh, sorry, again, Jared, is there any more detail on that question?
Here, Arturo, I'm gonna unmute you so you can ask the question. Go ahead. Arturo?
Yes.
Go ahead. If you can you provide some more detail to that question.
Sorry. Take me out.
Okay. Okay. If you, Arturo, if you have more details to that question, just feel free to email me at the email address that's in the chat. I will relay that. Okay. Ahmad and Carl, thank you guys so much for your time today. I really appreciate it. And we look forward to doing another one down the road. Thank you guys.